I have been able to collect some question of first paper of ECE. So, there are around 20 questions. So, I will discuss one by one subject wise. So, first I am starting with control system. The open loop transfer function is given as s plus 4 divided by s plus 8 into s square minus 9. In this question, we have to find out in the root locus plot, we have to find out value of k for which s equal to minus 1 plus j2 lies on the root locus. Open loop transfer function is given, and in the root locus we have to find out k such that this pole lies on the root locus. So, for solving this question, we first write the condition for which a pole or a point lie on root locus. So, this is the condition 1 plus k GSHS equal to 0, and this is the closed loop system, and the transfer function for this system is k GSHS divided by 1 plus k GSHS. So, 1 plus k GSHS lie in the denominator. So, zeros of 1 plus k GSHS will be the root of this closed loop system. So, if a point of S plane satisfy this equation, that point will be on root locus. So, if I proceed it, k GSHS should be minus 1. From here, modulus of GSHS must be equal to 1 by k, and angle of GSHS must be equal to, since minus is here and k has no angle contribution, so angle of GSHS must be equal to minus 180 degree. So, these are the two conditions. From one condition we are deriving two conditions such that a point S or a point S1 will lie on the root locus. Suppose if S equal to minus 1 plus J2 lies on the root locus. So, if we put in GSHS, if we put S equal to minus 1 plus J2, the angle of GSHS must come minus 180 degree, and the magnitude of GSHS must be equal to 1 by k, and we vary k from 0 to infinity. In root locus, k is varied from 0 to infinity. Now, if it is given that this point lies on root locus, then it will already satisfy these two conditions. So, from this condition we can find out the value of k. The value of k will be 1 by modulus of GSHS at S equal to minus 1 plus J2. So, k can be found out by this method, but in this question first I am checking it whether the angle of GSHS is equal to minus 180 degree or not. Angle of GSHS at S equal to minus 1 plus J2. So, GSHS is equal to, here we will put at the place of S minus 1 plus J2. So, this will become 3 plus J2 divided by, this is S plus 8, this is S plus 4 divided by S plus 8 into S plus 3 into S minus 3. So, S plus 8 will be 7 plus J2 into S plus 3. So, this will be 2 plus J2, and S minus 3 minus 3 minus 1 minus 4 plus J2. Now, the angle of GSHS will be, or angle of GSHS is equal to tan inverse angle of this. So, this is 2 by 3 minus angle of this is 2 by 7 minus angle of this quantity is tan inverse 2 by 2 minus angle of this quantity can be found out. The real part is minus 4 and imaginary part is 2. Real part is minus 4 and imaginary part is minus 2. So, the point will be here, and angle is always measured from x axis in anti-clockwise direction. So, this is the angle. This is the angle contributed by minus 4 plus j2. So, this angle will be, this length is 4 and this length is 2. So, this angle will be tan inverse 2 by 4. So, phi will be, phi is equal to 180 minus tan inverse 2 by 4. Now, for minus 1 plus j2 to lie on the root locus, angle of GSHS must be equal to minus 180 degree. I am first checking whether this point lie on the root locus or not. If this point will lie on the root locus, then I will find out the value of k using this condition. So, if s lie on the root locus, this equation will be satisfied. So, I am trying to satisfy this equation. Here minus 180, minus 180 is cancelled out. Tan inverse 2 by 3 plus tan inverse 1 by 2 minus tan inverse 2 by 7 minus tan inverse 1 equal to 45 degree. This is equal to 0. This will be tan inverse 2 by 3 plus 1 by 2 divided by 1 minus 2 by 3 into 1 by 2 minus tan inverse 2 by 7 must be equal to 45 degree. This will be tan inverse 5 by 4 minus tan inverse 2 by 7 equal to 45 degree. Now, this is tan inverse 5 by 4 minus 2 by 7 divided by 1 plus 5 by 4 into 2 by 7. This must be equal to 45 degree. Hence, you bring tan this side, tan 45 will be 1. So, 5 minus 5 by 4 minus 2 by 7 must be equal to 1 plus 10 by 28. This will be 27 by 28. This must be equal to, this is 38 by 28. So, the equation is not satisfied. This equation is not satisfied. Then the angle of GSHS at s equal to minus 1 plus j2 is not equal to minus 180 degree. And if this condition is not satisfied, this point is not on the root locus. And if this point is not on the root locus, there is no point, there is no value of k between 0 to infinity for which this point lies on the root locus. So, if this point is not on the root locus, there is no reason to find out the value of k. So, this question is not correct. This question is wrong. If without checking angle condition, if you try to find out value of k, the k is equal to 1 by modulus of GSHS. So, modulus of GSHS is equal to, this will be root under 13, this is 49 plus 4 53, this is root 8 and this is root 20. So, k will be reverse of this, root under 53 into 8 into 20 divided by root under 13. So, this will come around 25.5. This is given in the solution of gate forum. If for that, for value of for k equal to 25.5, this point lie on the root locus, but actually this point does not lie on the root locus. So this was one of the method. We checked the angle condition and we proved that this point doesn't lie on the root locus. So there is no question of finding out the value of k. This can also be proved by another method. So I am going to explain that method. Let us first try to find out the characteristic equation of the closed loop system. If this is open loop system, 1 plus k GSHs, the numerator of the transfer function is, the closed loop transfer function is k GSHs divided by 1 plus k GSHs. So 1 plus k GSHs will give you the characteristic equation, or zeros of 1 plus k GSHs will give you the characteristic equation. So 1 plus k into s plus 4 divided by s plus 8 into s square minus 9. This will be plus k into zeros of this equation will be found out. Okay. So this is the characteristic equation. Now if a point lie on the root locus, that means the point, suppose minus 1 plus j2, suppose this is alpha. If alpha lies on the root locus, then alpha will satisfy this equation. Means if we put alpha at the place of s, this equation will be satisfied. So this will be 0. So this is s cube plus 8s square minus 9s plus ks plus 4k. This is equal to 0 if a point lies on the root locus. Now let us say if this point is on root locus for some value of k, and we also know that root locus is also always symmetric about x axis. So on the root locus, suppose this is the root locus, this is minus 1 plus j2. If this point lies on the root locus, its conjugate will also be on the root locus. So minus 1 minus j2 is also on the root locus. So this point will also be on the root locus. Now if this is a solution of s for some value of k, this is also a solution of s, means alpha also satisfies this equation, beta also satisfies this equation. So this equation must be divisible by s minus alpha. If alpha is root of this equation, so this equation must be divisible by s minus alpha. Also beta is also the root of this equation, so this will be divisible by s minus beta. And if this is divisible by individually s minus alpha and s minus beta, so this equation will be divisible by product of s minus alpha and s minus beta. So first we are trying to find out s minus alpha into s minus beta. So s minus alpha will be s minus this quantity is s plus 1 minus j2, and s minus this quantity is s plus 1 plus j2. So if we multiply this quantity, we will get s plus 1 whole square minus j2 square. So this will be s square plus 2s plus 5. So if this lie on the root locus, this will also lie on the root locus, and if the 2 points lies on the root locus, the characteristic equation must be divisible by s square plus 2s plus 5. So we will divide the characteristic equation with this, and if it is divisible, remainder will be 0. Plus s cube plus 2s square plus 5s. This is 6s square minus 14s plus ks plus 4k. Here degree is 2, here degree is 2. So we will make one more division, plus 6s square minus 12s plus 30. When we multiplied here, we missed 8 into 9. So, here it will be minus 72. Minus 72 is missing, minus 72. This is minus 26s plus ks plus 4k minus 72 minus 30. This is minus, this must be equal to 0. This is the remainder and this must be equal to 0. Minus 26 plus k into s plus 4k. So, if this is 0, this quantity is s to power 1 and this quantity is to power 0. So, both have to be 0 individually. So, if this is 0, we are getting value of k is equal to 26, and if this is 0, we are getting value of k is equal to 25.5. That it means there is no value of unique value of k for which the characteristic equation is divisible by this equation. That means there is no value of k for which these two are on the root locus. Suppose if gate forum gives this solution k is equal to 25.5. So, if we put k equal to 25, this equation must be 0, but this will be 0, and if you put k equal to 25.5, this equation will not be 0. So, again the condition is not satisfied. So, if the question is wrong, everybody will get 2 marks. So, do not worry if the question is wrong. Second question of control system. Second question is, in a lead network, the feed forward path contains R parallel with C and the transfer function is given at s plus 2 divided by s plus 4. This is a lead network. We have to find out value of RC. So, I am first drawing a circuit for lead network. This is R1, this is C, this is R2. This is output voltage. In Laplace I am writing it as V naught by S. This is V naught S, this is V I S, this is C, and this is the transfer function is given. So, V naught S by V I S, this is given, and if I find out V naught S by V I S from this circuit, it will be R2 divided by, I am applying voltage division, R2 plus R1 parallel 1 by CS. This is R2 divided by R2 plus R1 parallel 1 by CS will be R1 divided by 1 plus R1 CS. So, this is equal to R2 into 1 plus R1 CS divided by R2 plus R1 R2 CS plus R1, or R2 into 1 plus R1 CS R1 plus R2 plus R1 R2 CS, or R2 divided by R1 plus R2 into 1 plus R1 CS divided by R1 plus R2 has been taken common. This is 1 plus R1 R2 divided by R1 plus R2 into CS. This is the gain into 1 plus R1 CS divided by 1 plus R1 R2 divided by R1 plus R2 CS. So, this is the transfer function of this lead network. This is in time constant form, 1 plus Ts, 1 plus another TCS, Ts, and here the transfer function is given in pole 0 form. So, first convert it into time constant form. Time constant form means here it is s plus 2, we have to make it 1 plus Ts, we have to manage 1 here and 1 here. So, from here I am taking 2 common, this will be 1 plus 0.5 s, and take 4 common from denominator, this will be 1 plus 0.25 s. So, this is 1 by 2 into 1 plus 0.5 s divided by 1 plus 0.25 s. Now, compare it. We are given that feed forward path contains R parallel with C, R parallel with C, and we have to find out RC means R1C. This R1C we have to find out. So, now compare it, K is equal to 1 by 2 and in the numerator we have R1CS. So, R1CS is equal to 0.5s. So, by comparing R1C is equal to 0.5, this is the correct answer. Coming to the next question. A transfer function is given as Gs is equal to 10 into s plus 1 divided by s plus 10, and the question is asked that the polar plot of GSHS will lie in first quadrant, second quadrant, third quadrant or fourth quadrant. So, for drawing polar plot in S plane, this is S plane, this is j omega axis, this is real axis. So, S is moved on imaginary axis. So, we will put S equal to j omega, there is no real part. So, we will say that j omega is equal to, and omega is varied from 0 to infinity. So, this will be the polar plot. J omega plus 1, j omega plus 10. Now, for solving this question, you just check the angle of j omega. Angle of j omega is equal to, 10 has no angle contribution, it has angle contribution of tan inverse omega by 1 minus, it has angle contribution of tan inverse omega by 10, and omega is varied from 0 to infinity. In j omega plane, this is imaginary part of j omega and this is real part of j omega, and angle of j omega will be measured from x axis. So, if the angle of j omega varies 0 to 90, this will be in first quadrant. If this is 90 to 180, this will be in second quadrant, and so on. Now, angle of j omega is equal to tan inverse omega minus tan inverse omega by 10. Notice that omega is varying from plus 0 to plus infinity. So, this angle cannot be greater than 90 degree. The maximum limit of this angle is 90 degree. Again, here also limit of this angle is 90 degree. So, both the angles are less than 90 degree. So, their subtraction must also be less than 90 degree, and omega is always greater than omega by 10. If omega, as long as omega is positive, omega will always be greater than omega by 10. So, the angle contributed by this term will always be greater than angle contributed by this term. So, this subtraction will always be positive and the magnitude will always be less than 90 degree. So, this is positive, this angle of j omega is always positive. So, we will say that the angle is always greater than 0, and since none of the angle is greater than 90 degree, so their subtraction will always also be less than 90 degree. So, the angle of j omega is 0 to 90 degree. So, this will be in first quadrant. So, this is the correct answer. If you will draw complete polar plot of j omega, this will be like this. When omega is equal to 0, you will get 1 and angle equal to 0, because both is contributing 0 angle. If you will, let us say if omega is equal to infinity, this term is dominating and this term is dominating. So, this will be 10 j omega divided by j omega. So, it will give you magnitude of 10. So, the distance from origin will be 10. If you try to find out angle of Gj omega when omega is equal to infinity, this will produce 90-degree angle, this will also produce 90-degree angle. So, again 90 minus 90 will be 0. So, at omega equal to infinity, angle will again be 0, but the magnitude is 10. This is 1. So, this is the polar plot when omega is equal to 0 to infinity, and this will be the polar plot when omega is equal to minus infinity to 0. In this question, we have to find out value of k for which the root locus crosses imaginary axis. If we plot root locus for this system, the open loop poles are at 0, -1 and -3, and its root locus is like this. This will, as we will increase k, this will go to minus infinity. These two poles will come closer, and there will be some breakaway point as we increase the k. These are the location of pole for k equal to 0, and when k is increased, the poles are moving, and at some value of k, the roots will cross imaginary axis. Suppose this is s equal to j omega, and here s is equal to, because on imaginary axis there cannot be a real part of s. So, I am just writing s equal to j omega and s equal to minus j omega. So, first I am solving this question with the help of root locus Routh-Hurwitz criteria, because if for some value of k the roots are on imaginary axis, then for that value of k, system will be oscillating with omega frequency. So, system will be oscillatory. So, in the Routh-Hurwitz table, one complete row will be 0. So, first I am finding out the characteristic equation, then I will write down Routh-Hurwitz table, and then we will go for the condition of marginal stability. So, the characteristic equation will be 1 plus k GSHS. So, this will be 1 plus s into s plus 1 into s plus 3. So, the characteristic equation will be, this is s into s plus 1 into s plus 3 plus k. This is s cube plus 4 s square plus 3 s plus k. S cube, s square, s to power 1, s to power 0. This is 1, this is 3, this is 4, and this is k. So, here we will have b minus ac by d. This will be 3 minus k by 4, and this is 0. So, for system to oscillate, this complete row must be equal to 0. So, 3 minus k by 4 must be equal to 0. So, k must be equal to 12. So, this was using Routh-Hurwitz table. I am explaining another method. Suppose for some value of k, the poles are on imaginary axis, and let us say the pole is j omega and minus j omega, because root locus is symmetrical about x axis. So, if j omega is a root for this equation, minus j omega will also be a root. If j omega is a root, so the characteristic equation will be divisible by s minus j omega, and if minus j omega is a root, then characteristic equation will be divisible by s plus j omega, and if characteristic equation is individually divisible by s plus j omega and s minus j omega, so this will also, characteristic equation will also be divisible by product of these two. The product of these two is s square plus omega square. So, we will divide the characteristic equation by s square plus omega square, and we will try to make the remainder 0. S cube plus omega square s, this is 4 s square minus omega square s plus 3s plus k. Now, this is the highest degree. So, plus 4, this is 4 s square plus 4 omega square, this is cancelled, this is minus omega square s plus 3 s minus 4 omega square plus k. Now, degree of remainder is 1 and here the degree is 2. So, we will not make further division. So, this is the remainder, this is s component and this is s to power 0 component. So, both have to be 0 individually. So, to make it 0, omega square must be equal to 3, and if we will use omega square equal to 3, we will have value of k 4 into 3 12. So, the value for k equal to 12, the system will oscillate and system will oscillate with a frequency omega square equal to 3. So, the omega will be root 3. So, the pole will be, first pole will be j root 3, this is the first root, the second root is minus j root 3. Now, when we divide it by s square plus omega square, this is the answer. So, minus 4 will also be a root of this this characteristic equation. So, minus 4 will be the another root. So, for k equal to 12, the roots are j root 3 comma minus j root 3 and minus 4. In this question, a block diagram is given and we have to find out poles of the location of the pole of this system. This question looks like a question of signal system, but we can solve it using signal flow graph or block diagram reduction also, but I prefer signal flow graph. Okay. So, I am starting with xz. Here we have a node and gain is 1. Again here the gain is 1 and node, again the gain is 1, then a node, and then we have yz here. From this node to this node, we have a feedback of 5 by 6 into z to power minus 1, 5 by 6 into z to power minus 1, and from this node to first node, we have a feedback of minus 1 by 6 z to power minus 2, minus 1 by 6 z to power minus 2. So, yz by xz will be, there is only one forward path and forward path gain is 1 and both the loops are touching forward path. So, this will be 1 divided by 1 minus L1 plus L2, 1 divided by 1 minus L1 is minus 1 by 6 z to power minus 2, minus 1 by 6 z to power minus 2 plus root 2 is 5 by 6 into z to power minus 1. So, this is 1 by 1 minus 5 by 6 z to power minus 1 plus 1 by 6 z to power minus 2. This is equal to 1 minus 5 by 6 can be written as 1 by 2 z to power minus 1 minus 1 by 3 z to power minus 1. 1 by 2 plus 1 by 3 is equal to 5 by 6, 1 by 6 z square. So, this will be 1 minus 1 by 2 z to power minus 1 minus 1 by 3 z to power minus 1, z to power minus 1 is taken common. So, here we will have 1 minus 1 by 2 z to power minus 1. So, this is 1 by 1 minus 1 by 3 z to power minus 1 into 1 minus 1 by 2 z to power minus 1. So, the poles are at z equal to 1 by 2 comma 1 by 3. In this question also we have open loop transfer function. Open loop transfer function is given and we have to find out for a system to be stable for unity feedback system to be stable, what is the condition for the unity feedback system to be stable. So, again we will find out the characteristic equation and by applying Raoult-Hurwitz criteria we will find out the condition. First I am drawing the block diagram of the control system. This is Kp, Ki by S, and this is system transfer function S into S plus 2. This is proportional controller, this is integral controller. So, this is PI controller and unity feedback. This is a reference, this is output. So, the characteristic equation will be equation is 1 plus Kp plus Ki by S into 1 divided by S into S plus 2. This is S into S plus 2 plus Kp plus Ki by S divided by S into S plus 2. This is characteristic equation. Or numerator of this part is will give you the characteristic equation, because this will go to the numerator of transfer function. This will be in denominator. So, this is S square S plus 2 plus Kps plus Ki. This is S cube plus 2S square plus Kps plus Ki. Now, make the Raoult-Hurwitz table. This is 1 Kp, 2 and Ki. So, here we will have B minus AC by D and 0. For system to be stable, Kp minus Ki by 2 must be greater than 0. So, 2 Kp must be greater than Ki, and this is given in option B.